Hi engineering students, welcome to the second video for week 2 of our coding. This is video 2B. And once again, we're going to start off this lesson with recapping a little bit of what we already did and trying to show you some more elegant methods to clean everything up and give you some extra tips and tricks. So here we go. On the left, I've got pretty typical code. It's a little bit shorter than what I was wanting from you, especially I heard about Davis doing his hundreds of lines of code. Not necessary, but very cool. Keep it up. But this is like a little snippet, and I just want to illustrate a few things here. So hopefully you can look at the lines of code at this point and really sort of predict what is going to happen. We're just saying, hey, let's help you get dressed in the morning. It's going to ask for the input, describe the weather date. Notice the use of \n to create the new lines. It's a little more elegant than repeated empty print functions. And it's going to drop that input into the function called weather. Then line 3 is converting weather into its lowercase form. It's redefining a variable in terms of itself. And then we're going through a bunch of cases. We have our if, elif, elif, and then finishing with an else that kind of catches all the other everythings. And I am, in each case, saying if weather equals sunny, well, I want to wear shorts and t-shirt. But also I'm thinking, well, what if they type hot? Okay, let's wear shorts and t-shirt. If they say warm, like how many other ways could we say the kind of weather that would result in you wearing shorts and a t-shirt? And I thought of this because I was looking at, I believe it was Cassie's code, and she tried to do this. She wrote a bunch of different similar things. She accounted for the fact that a person might say, it is sunny, or they might just write the word sunny. And that's very possible with a text-based input. There's an infinite number of things a person can write. So you can try to catch a lot of those things. You can try to prompt the user, like you might, in this line, you might say, is it, sunny, hot, cold? Like you can try to help them and guide them. Another way to do that would be to like have a numbered list with like numbers 1, 2, 3, 4. I saw some people use that. Then they have them type in a number. But let's say that we just leave it open and they can write anything at all. So you could make a list of things, but notice that sunny, hot, and warm all result in the same outcome. Cold, windy, and very cold all result in the same outcome. So we can make this kind of code a little more expeditious, a little more efficient. And we can do it with an OR function, an OR logic operator, I should say. This is OR, I mean, right there, OR. OR is a little piece of logic that says, like this thing or this thing. It could be both of those things, by the way, with an OR function. But if we at least have one of these things, then we're going to trigger a true result. And remember, that's what the if statement is all about. If we get a true result, a true logic result, then this indented line happens. If we don't get a true, if we get a false, that's the only other option, then it starts checking the others. And if we never get a true result, then it's going to run the else at the very end of that paragraph, for want of a better word. But we can do this. We can actually put all of these things, oops, hold on, there we go. We actually put them all one by one. They each need their own little equivalent sign. But we can say if weather equals sunny, or weather equals hot, or weather equals warm, then we just don't need all of those. And I'm actually going to delete them because we really don't need them. Over here, I can say windy or weather equals very cold, and honestly, any other phrases you can come up with, then we are going to tell them to wear the long pants and the jacket. And if they don't say any of those things, well, yes, we just give up and we say, I don't know how to help you with that. Describe weather today, it's warm. All right, you should wear shorts or a t-shirt. Describe the weather today, it's hot. Wear shorts or a t-shirt. Shorts and a t-shirt. It is windy. windy. It is windy. Wear long pants and a jacket. It is cold. Wear long pants and jacket. And if we say it is cold, okay, because we just don't know, I don't know how to help you with that. Okay, you might be wondering, why did that line just appear there after I was done? Why did it say describe the weather today again? Well, it's because I have something hidden down the bottom. I want to show you something else, and I've got it tucked away below. I didn't scroll down on purpose. So here's what I want to show you next. It is possible to do what is called data validation, and you should be taking notes. Can you please write down that phrase, data validation? That is a phrase that means we are going to check the input of the user, and we're going to ensure that it actually fits the kind of input that we want. And if it doesn't, we're going to throw it back and ask for it again. Okay, so if in this case, if the person doesn't put a text string that matches to something we're expecting, we're just going to re-ask the question until they say it. Now, because there are an infinite number of text strings you could type, this could take a while, but we hopefully, speak English. We're going to do common sense inputs. We're going to say the kinds of things and not random words like ice cream and elephant. Hopefully we're not going to type in numbers. So, you sort of rely on the user a little bit. But here is the code I'm going to insert in. And I did pre-type this just to be a little faster, but then I'll walk us through it. Here we go. Let's look at this. It's always hard when a block of code just drops in, but let me talk you through it. We're going to use one of these while loops. And the while loops, I did just kind of throw this in. I actually wasn't really meaning to throw them in the last video, and then it just seemed very natural to bring them up, so I did. But the while loop, if you remember, yeah, let me put some comments in here. This is called data validation, checking for correct input. The while loop runs and runs and runs over and over again. It's kind of like an infinite loop, if you like, until the condition is broken. Until whatever is in here, like between the word while and the colon at the end, until that comes up as false. Okay, so for as long as that is true, as long as this highlighted part I have right here comes back with a result, a logic result of true, the while loop will keep running. And the while loop is this part right here, lines 7 and 8, shown by that little vertical line right there. When you get a false, it breaks and the code will jump down to line 10 and actually start checking those cases. So here's what it does. It says, while the input is not equal, remember this, that's what this means here, not equal to, while the input is not equal to the word sunny, and while it's not equal to the word hot, and these are logic operators, by the way, and it's the same idea as or, but it's and needs two things or more, or two or three or more things to be all correct. And the word is not warm, and the word is not cold, and the word is not windy, and the word is not very cold. Okay, so we're saying if all six of those continue to hold as true, we're going to keep running this. That's what I've done here. I've linked all 6 of those together into one long and. I need all of those things to be true. And if they are, this will keep running. And what is it running? It's continually asking me to describe the weather today. It's actually restating the question that was back up here. So what this does is it says, if I run this and I say, it is cold, it re-asks the question because cold didn't fit any of those 6 possibilities that I listed off. Python checks this and it says, it looks in the variable called weather and it says, is cold not equal to sunny? True or false? Is cold not equal to sunny? That's true. Is cold not equal to hot? That's true. Is cold not equal to warm? Is cold not equal to cold? Is cold not equal to windy? Is cold not equal to very cold? Those are all true. All 6 things are true. Therefore, true and true and true and true and true and true. The whole thing is true. So it keeps running this. Now, as soon as I type, well, I guess I'll do it again. As soon as I type wildly windy, as soon as I type a word like the word windy, suddenly this one here is no longer going to show up as true. It's going to get to that. It's going to say, is windy not equal to windy? Now think that through. Is windy not equal to windy? That's false. It's kind of like double negatives. You got to think through this really carefully. The answer to that is false. And when you have one false, when you have true and true and true and true and false and true, that results in a false outcome. Because and statements need everything to come back as true, to be true. Okay? Now, ordinarily, guys, we'd go through a whole section on logic for a couple of weeks before we hit this. So I know I'm just sort of giving you the really fast version of this. But if you want to use data validation, this is one way in which you can do that. Let everything be true, and then it will keep asking. And the loop gets broken as soon as any of those come back as false. Okay. I think I will leave that there. For those who wish to use that, you can. For those who feel a little confused by that, that's okay. This is just kind of embellishments. I'm pitching this a little higher because I want to give a little more for those who are ready for it. All right. Let's get into the new stuff now. And let's see. I think I want to leave it like there. I think I might just comment a bunch of this out. I'll leave it there for you to look at when I share this. Otherwise, oops, you can collapse that. That's what's happening there. There's a little tiny plus and minus arrow that come up. Yeah, we'll just comment all of that out. There we go. We'll let it ask the first question. That's fine. What to say? What's the weather today? It's windy. Doesn't matter. We're not going to do anything with that. Okay. So what we're going to look at today that's new is something called iterations. I'm going to use something called for and in and also range. Okay, these are 3 new things that you will see now. So you can write these down in your notes, get ready to like kind of, leave some space. You might want to describe, write some examples, things like that. For, in, and range. Okay, so first of all, I think I'll show you for to begin with. So for is, it's a little tiny bit like while, okay? While is a way of looping infinitely until you come back with a false result, and then the loop breaks. For is a little like that. For runs the loop over and over, but as it's doing so, as it kind of like counts through a certain number of steps that you want to give to it. So it's not an infinite loop. It's iterating. It's counting across a range of things. If that sounds confusing, let me show you how this works. So let's create a little variable here. Let's say, well, I guess we already have one, don't we? We already have the word weather. So we're going to use this word weather. So we're going to say this. You say for n in weather, and then we're going to use a colon again. This is a similar sort of structure. Now, what is this letter n here? N is actually another variable. Okay, n is like a counting variable, if you wish. So I could have written anything here. I could have said for C, like I could have said character, like as in text character. I could have said for placeholder, but I don't want to write anything very long. I'm just going to use a very simple thing. So variables can actually be single letters. Okay, I generally recommend using actual names for variables when you have things like weather descriptions, because you often have dozens of variables in a code and you want to remember what they all are. But for a quick little counting variable that's sort of disposable, kind of throwaway, I recommend just the use of single letters. Okay. And oops, you know, it always gets a little weird when I put my comment right there. I'm going to put that here. And then my indents should work automatically. There we go. See, it put in the 2 spaces by itself, but it doesn't seem to do that when I have a comment stuck on the end. You can double tap those manually as well to put it in yourself. Okay, so for n in weather, print n. Okay, so what is this going to do? What this does is this takes your variable, in this case, the variable weather, which is a text string. You can see, like on the screen right now, I typed in the word windy, okay? And what for does is it steps through the word windy character by character. Okay, that's what for does. It steps through the word windy character by character. And that's how it decides to loop. It will actually loop for as many characters as you have in the word right now. I have 5 characters, W-I-N-D. So it's going to step through 5 times, and n, as it steps through each time, n is going to be temporarily each of those 5 characters. So let's see if I run this. Windy. 5 times it's going to go through. It's going to temporarily use the letter n for each of those 5 characters, W-I-N-D-Y, and the loop that I created is simply this: just print the letter n. Sorry, the variable n, not the letter n, the variable n, which first is W, then is I, then is n, then is D, then is Y. Does that make sense? You got to do these a few times before they really sit home. Other ways you could do this. What else could you do? I don't know. You could print it 3 times. I don't know why you would do that, but it is hot today. So I can go H-H-H-O-O-T-T-T. I didn't show you that, by the way. I could have showed you that. I don't think I did. You can actually take text, and if you do like multiplication on text, it'll just make it happen multiple times. I could say n plus space. Let's do that 3 times. Okay, that's going to take each letter of text, add a space to it, and do that thrice. See how those spaces are now appearing? There's a space there, space there, space there. Now, why would you want to do this? Well, I'm not quite sure. I can come up with it. Well, actually here, there's a really good example, and I'll do that right now. I am absolutely stealing this from a website called Grok Learning. It's out of Australia, but I really like their example here. So you could do something like this. you could say, give me a you try to work out what is happening here. For n in weather, it steps through the letters in whatever is in the whatever is currently in the variable weather, and it's going to say, give me a, it's going to speak the letter, comma, and then say it a second time. In fact, I wonder if we could really shout that. Let's try it. Let's try this. Windy. Give me a W. W. Give me an I. I. Give me an N. N. Give me a D. D. Give me a Y. Y. And then you'd probably, I mean, you got to finish that off, right? What does it spell? And we have to shout it at the end, right? Weather. Print weather upper. With an exclamation. There you go. Little very quick cheerleader program. It is windy. Give me a W, W, give me an I, give me an NN, give me DD, give me YY. What does it spell? Windy, shouting. Kind of dumb, but what is really interesting about the for in technique is just how compact and, you know, efficient that is. I have 4 lines of code which generated all of this. And even if I, you know, had said ridiculously hot, I mean really hot. Uh-oh. Okay. I think that's funny. You don't think that's funny? I think that's very funny. And your very annoying cheerleader program writes all of that out and then yells it back at you. Ooh, with a period and exclamation. So anyway, you see, like, in all of that is generated just from this for in loop running over and over again, iterating through each character of text. So that's a for in. Now there's other ways to use this loop as well. I think I will just keep on going here. You can also do some work with numbers, and we're going to use something here called range. Now notice that range is showing up as kind of a, what would you call that? Almost like a dark teal sort of color. You get that same color. Let me just get rid of that for a second. You get that same color when you just type in numbers like integers or floating point numbers. So that tells you we're kind of talking about something to do with numbers here. And what range is, a range is actually it's like a list. It's like a list of integers that, you know, kind of counts forward in a way that you define. Here's the easiest way to do range. You can just type a single number. And again, we're going to do print n. All right, check this out. First of all, so are they hot? See what we got there. Forget all the hot stuff. Forget all the hot stuff. That sounds weird. Forget the cheerleader. Notice what range is doing here. When it does for n in range, it's stepping through everything in that list that you created. Like that little bit of text here where it says just range parentheses 5. That, in the back end, in the secret world, behind the curtain in Python, is actually 5 numbers. Now, write this down in your notes because this is hard to remember, at least at first. Range, by default, starts counting with the number 0. And it stops before it gets to the number that you specified. So when you write range 5, you get 5 numbers, I guess you can think of it that way, but it starts at 0 and it ends at 4. It ends before it gets to the 5. You know, obviously, if I do range 10, it is hot. I get all of that, but I don't get the 10 itself. And I start with a 0. Now, if you don't want to always start at 0, then there is a very easy way around that. Range, the function range, can accept multiple arguments to help control it. If you just have one argument, like I did here, just the number 10, it starts at 0, stops before it gets 10. But you can say, hey, let's begin at 1. Like, you can tell it where to start. If I do that, it will start at 1. Now, it still doesn't go up to 10, so it is best if you don't think of that number 10 as being the number of integers in the list. It's not. It's just the signal as to where to stop. Okay, I can say 8. Again, it's going to start at the 1 I specify. It's going to end before it gets to the 8. Like with all functions, you can put spaces there if you prefer. You know, it's very forgiving, as I often tell you. So if I wanted the list of numbers from 1 to 10, what would I have to put in that range? I want 1 to 10. Well, I got to put in the 1 at the start like I have, but I've really got to then put 11. I have to put the number that I want it to not get through if I want to count from 1 to 10. One last, actually maybe there's a couple of other little tricks I'll show you here. Range can accept a third argument. By default, it counts by ones, you know, like any kindergartner does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you want, you can tell it with a third argument that you want to count by 2s. It's hot, it's still hot. And so it's going to say 1, and then it's going to start counting by 2s. 3, 5, 7, 9. And again, it won't include the 11. It'll just, if it gets to 11, it won't show that. Okay, sorry for a little blip there. Just got interrupted. I'm back. Okay, now there's another few tricks that I will show you as well. You can also count backwards. And you know what? I'm doing this from memory. I think you have to flip those 2 numbers. Let's try that. Okay, yep. Flip those 2 numbers. And once again, the same pattern happens. You tell it which number to start with, but you tell it the number that you don't want to get to, okay? The one you want to stop at. So if I wanted to count from down from 10 to 1, like a blast off, that's how I'd have to do it. Okay, start at 10, counting backwards in steps of -1, don't get to 0. I'm sorry, I just feel like I have to say that. All right, good. All right, that handles that, I think. So, you know, how might you use that? So these kind of iterative processes are actually fairly common in math and science and engineering. Let me see here. Like, what if you wanted to build? I'm just making this up as I go along. Let's see how this goes. What if you wanted to build a table of xy values for a linear function? Okay, like imagine you have. All right, I'm gonna. Yeah. All right, I'm gonna comment out this part now. Oops. What if you wanted to say, you know, I'm going to make a little quick thing here, and this is good because you get to look over my shoulder as I code and this is supposed to show you how the process actually works. So let's do this. Print. Let's output XY coordinate pairs for a linear function. Now, I hope you all know what a linear function is. Freshmen might be the only ones at all maybe confused by that. You did do it in middle school. It's like a y equals mx plus b kind of thing. So let's say let's say input, oops, give me the slope of the function. You know, that's what the m is. I think you know that. So we're going to put that in a variable we just created called m. We'll do the same thing. Give me the y-intercept of the function. And as you know, there are only two variables. Okay, let's just check this works. Type. Okay, let's output so functions. Let's say we had like 2 and -1. Okay, great. So that's going to work. Probably not going to do the blast off thing. In fact, with only 3 little hashtags, I don't know why I'm still doing that up there. All right, now, okay, so let's go back here. Let's say we're going to do from 1 to 10. I'm going to take away the third argument. I don't need to define steps. Let's just have the default steps of 1. You could control that. You could actually ask questions up front and ask the user, like, what range of values do you want and what increments do you want? And then you could actually have those as variables and then use them in the range. Maybe I'll show you that after we're done here. But this is going to say for 10 different numbers, okay, starting at 1 and not getting to 11, we are going to print a few things. We're going to say parentheses plus, what do we want? We want the x value, so that is going to be the n. Okay, n is the temporary counting number that's clicking through. In this case, those are the x values. If you're at all confused, I think you're going to see where this is going once I've done it. And then here, we're actually going to input the y values, the output, which is the mx plus b. We'll say m times n. You know what, let's put it all in parentheses. M times n plus b. And you know what, let's make this even easier on our poor little addled brains. Let's actually, you know, I think I can replace that. Look at this. No, that's all right. Let's not do it. I was going to show you a little trick, but I think it might have unintended consequences. Okay, and we'll finish with with the closed parentheses. Closed text parentheses, by the way, not actual like operative coding parentheses. All right, look at this. See what's going to happen here. This is going to count through a bunch of x values, like x is like your input, starting with 1, going up to 10, and it's going to open some parentheses. It's going to put the x value, then put a comma, a space, then it's going to run the linear function, m times x plus the b, then it's going to close with parentheses. Let's see if this works. Let's see if I didn't make any mistakes. Let's output x, y coordinate pairs for linear function. Give me the slope of the function. 2. Give me the y-intercept of the function. 3. Ooh, I got a mistake. Oh, did anyone see that was going to happen? What did I do wrong? This is why I want you to see me coding. That's why I want you to look over my shoulder and see me doing this. I didn't turn those numbers into strings. Remember that if you're going to concatenate different things, different bits of text in a print function, you have to force the integers. X is an integer. This calculation here is an integer. You got to force them to become strings. There you go. Let's try that again. 2 and 3. Ah, look at that. That doesn't feel right. That does not feel right. I don't think it's 23. 223. Something is completely up here. Let's see. Oh, I see. I'm getting, you know what's happening again? I'm still getting confused between strings and integers. And this is me as your teacher. So isn't this a little suspicious? See what it's doing? It's taking the 2 that I input, but it's not an integer, it's a piece of text. So when it gets down to here, it's taking my piece of text and it's multiplying it. I just did air quotes, you saw that. It's multiplying it by whatever x value we're up to. So when we're up to x equals 1 or 2 or 3, whatever, it's just simply writing the m, 2 or 3 times whatever this x value is, and then it's tacking onto the end whatever this piece of text is, but not in a number sense, in a text sense. Like, watch this. Give me the SOAP function, cat. Give me the y-intercept function, dog. Ooh. Okay, you see what's going on here? It's going through. Now this x, that is really the only integer that's happening in this whole thing. That's a real integer that I'm jamming, forcing it to be a string. What do I need to do? Can I do this? Can I convert the input into an integer? Yes, I can. That is what I'm going to do. Let's see if this works now. 2, 3. Ah, that's what I want. Okay, and there are my XY coordinate pairs. No, that's fine. I like that. That builds up a quick little table for me. This is good. And you could make this even fancier, as I said. Let's put a little more variability into it. And then I think I'm almost ready to give you your challenge for this second video. This might be a bit of a shorter video. I'm going to say, yep, I'm making integers right from the start this time. Input, which x value would you like to start with? Great. By the way, you've probably noticed with Python that we actually, when you do your opening parentheses, it immediately puts in the closing one so you don't forget about it. I love that Replit does this because most coding interfaces that I have used don't. And the number of times you just simply forget that back parentheses, it's crazy. Okay, and let me be a little more schmancy and put stuff there, which actually I like to end with, oops. And we'll call it step. I don't think step gets used, no. Control C, Control V. What if we say, like, what increment would you like to count with? And now we get down to our range, and we're going to pop in our arguments. But we're going to use the variables to do it. And because they're all integers, integer, 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 it's going to receive those just fine, I think. Now, I actually know there is one problem with my code right now. I don't know if anyone spotted that. You have about 10 or 15 seconds before I reveal what is incorrect. Let's see. All right, give me the slope. You have about 3 seconds left. Oops. Hold on. You still have about 3 seconds. Here we go. 2, 3. Which x value would you like to start with? 1. Which x value would you like to end with? Okay. You still have time. Hold on. This is bugging me. Sorry. I am really feeling the need to clean up things a little bit. Let's try that again. Give the slope function with the y-intercept. I'd like to start with 1. I'd like to end with 10. I'd like to count in increments of 1. Okay, you have 3 seconds left. What's my problem? Oh, look at that. Do you see the problem now? Remember that range starts with the number you want to start with. But what goes here in the second argument, it's not actually the number you want to end with. It's actually the number that you don't want to end with, the number that you want to not get to. Weird, I know, but that's how it works. So we solve this. Now, oops, I did see this coming. We do end plus 1. We just simply add one more counting integer onto whatever the user typed in, because the user is going to put in what comes naturally. Okay, they won't feel the need to add 1 manually because they know there's a range function happening inside the program. No, so you got to do that for them because you know how a range function actually works. Now let's see how this goes. 2, 3. We're going to start with 1. We're going to end with 10. We're going to count in increments of 1. There we go. We went from 1 to 10. Let's try a few other things. 2, 3. Could we start with 0 and with 9 in steps of 2? Yes, we can. 0, 2, 4, 6, 8. And we still get the correct numbers. Could we do negative numbers here? I would like to start with -5 and go to +5 in steps of 1. Yes, we can. Okay, it works. So again, this shows you a very, very practical use of how of how you might be able to use this. Now, for your projects, your little mini coding project for the second half of this week, I would like you to do something kind of along these lines. This won't be very difficult. Please, let's see. Please create a program that generates the squares of numbers. Oops. According to the input given. When I say according to the input given, I mean I would like you to ask them, like, what number would you like to start with, what number do you want to end with, and what increments. And I want it to create the squares of those numbers, okay? Like, as in the square of 2 is 4, the square of 6 is 36, the square of 10 is 100, those squares. So the user is going to say the series of numbers they want, and the output is going to be the squares. Now, I'm going to leave you some creativity here if you want to add in more than that, if you want to do something with those squares, if you want to have them appear as coordinate pairs like this, or if you want to have it appear in a different kind of way, you can do that. Actually, you know what? The last thing that I will show you, this is just bonus stuff, because you might want to use this. Let's see. Yeah, we'll do the same range. Another little trick you can do, don't forget that colon, is you can do x equals x plus, how do we do this? Can we do x equals x plus, oh, hold on. I'm going to glance at something else. Forgive me. Okay, that's what I'm missing. I'm going to say this. Let's create a separate variable here. We're going to say output equals. So I'm going to quickly define a little variable here, which is defined as a text string variable because I made it a blank string. And I'm going to do this. I'm going to do output equals output, like redefine in terms of itself, plus this stringified x integer, and maybe even a little space as well. Okay, look at that. Look what's happening here. We have a particular string variable called output, and then as this steps through that range of numbers, it's going to take that text variable and it's going to continually redefine it as itself plus the new number in the series tacked on and a space tacked on. Watch what this does. Sorry, I'm going to march through all this other stuff. 10, 1. Oh, I got to print it. Sorry, I didn't print it. At the end, we are going to print output is already a text string, so we can simply do that. All right, let's run through that again. 2, 3, 1, 10, 1. Here we go. All right, see what that does? This here, all of this here, that long text string is the variable output right now. We started with it blank, and then using the for thing, the for in loop, we kept adding to the text string one by one as it counted through those. If it's helpful, you might want to look at it this way. What if we printed it each time? And I'm just going to comment that out for a second. Watch this. Come on. 2, 3, 1, 10, 1. You see that? Now I'm seeing the printout of the variable output as it is continually changed and added to over each for iteration. See, I'm printing. See how print is now within the loop. So it's printing each time. And then obviously the very last time that it does it, it has all 10 numbers attached to it. Okay, so that is another way that you could choose to generate your output for this little project. Okay, you can generate the square of the numbers according to the input given. If you want to do them as coordinate pairs as well, you could do it that way if you want them all to appear on the same line. If you want to do anything else that you can imagine with that, but I want to see that you can use that for in loop with a range and doing some kind of mathematical operation on it, just like here. All right, we're going to call it good there. I'm glad I dropped that in at the end there. I look forward to seeing your code. Thanks, guys. Keep it up.